Hello everyone, my name is Viraj, and today we'll be looking at the first problem from the CP-31 sheet by TLE Eliminators under the 900 rated questions. Let's go. So I'll be moving on to my CP-31 sheet over here, ticked off the 900 rated parameter. First problem, forked. Let's open this problem. Okay. Lunchbox is done with playing chess. His queen and king just got forked again. In a chess, a fork is when a knight attacks two pieces of higher values, that is commonly the king and queen. Lunchbox knows that the knights can be tricky, and in this version of chess he's playing, knights are even trickier. Instead of moving one tile in one direction and two tiles in other direction, knights in Lunchbox modified games moves A tiles in one direction and B tiles in the other direction. Alright. So Lunchbox is playing chess on an infinite chessboard which contains all the cells x, y, where x, y are they can be possibly negative also, that's fine. And Lunchbox's king and queen are placed on some cells xk, yk and xq, yq respectively. Find the number of positions such that if a knight is placed on that cell, it would attack both the king and the queen. Alright, so let us try to understand this problem. We'll generalize this and see what is happening. So what are they saying is, of course, we are talking about a game of chess. So we would need some board. I'll draw a very rough board over here. Okay. And this board that they have said is a chess board and it's kind of an infinite board. So basically the cells are infinite. They are expanded in the 2D horizon. Now, what are they saying is there is a knight which you have. I have a knight with me. And then I have a king also. I have a queen also. Now, initially, like I can give them some colors. Let's say king is this color, red, and queen is this blue color. So they are initially placed at some location. So let's say maybe this was where the king was placed. Same color thing. Maybe let's say this was where king was placed. And let's just say this was some place where queen was placed. Now, what are they saying is normally how, if you're familiar with chess, what happens when a knight moves is basically, if let's say this is my knight over here, then my knight either moves in, like it moves in such a way that it moves two jumps in one direction and then one jump in the other direction. So maybe it moves something like this, 1, 2 and then 3. So this is basically saying I moved 2 in this direction and then 1 in the other direction. Or maybe it does something like this, 1, 2 and like 3. So this sort of a movement that knight does is kind of limited to the fact that knight, by its virtue inside a normal chess game, is moving with 2 and 1 numbers in any of the direction it wants to go. Now this problem, what they are generalizing is, you have a knight, but the knight's movement is tricky. It can move A tiles in one direction and B tiles in the other direction. So let's just say that in this only, if let's say I say something like this, that I have A as 2 and then B as 3. That means I can choose to move 2 tiles in one direction. Maybe let's say I go up 1 and 2. And then let's say I want to move maybe 3 tiles in the other direction. So maybe 1, 2 and 3. So this sort of a movement that I've done is kind of tricky, and now the knight has come to this position. Knight is standing at this position. So we can understand that, okay, this knight is a bit tricky. It moves A tiles in one direction, B tiles in the other direction. Now what is given to us, or what is asked to us? They are saying that since you have an infinite, you can say infinite chessboard where it's expanding in a 2D horizon, there are of course some beginner places or some initial places the knight can be kept. And that knight being kept there can of course attack the queen or the king from some location. We want to find all such positions where we think that if the knight is kept, he will attack both the king and the queen. This is the argument. This is the problem solution that we are trying to find. Tell me the number of positions I feel on that 2D chessboard, 2D unlimited positioned chessboard, which such positions are there on which the knight will attack both the king and the queen. So if we look at the sample case, we'll understand our ideology very quickly. Let's say over here, when we had something like this input, this said that I can move. So they are saying that the input is A, B, giving initially on the first line, then xk and yk, that's the initial position of the king, and then xq and yq, that's the initial position of the queen. So the first input is 2, 1, 0, 0 and 3, 3. That means the knight can jump 2 and 1 tiles in one direction, and the king is initially at 0, 0 and the queen as initially as 3, 3. So basically they have created this sort of a diagram for themselves where they said, okay, so there's some position as 0, 0 and king has kept us like this. And now what they're saying is, if you look carefully at this knight, picture this knight being kept at this location can move 2 positions totally in one direction and then 1 position in some other direction. So basically I can say, okay, if let's say it moves up, so it goes 1, 2, and then it can move either one direction to the left or right. So basically one like this or maybe one like this. That's why these 2 blocks are marked as orange. Similarly, if it tries to move a bit to the, like it moves 2 directions to the left, to the right. So 1, 2, I think you can see my cursor mouse, and then 1 up or 1 down, that is that B equals to 1 position. So these 2 blocks are also turned orange. Similarly, these 2 blocks are also orange, these 2 blocks are also orange. So I can understand that, okay, out of all these 8 boxes that are turned orange, I can very clearly see that the king and the queen, alright, both are being covered by this knight. That means if the knight starts off at this particular block that's currently kept, it will be able to attack from this location both the king and the queen. So I know that this position can be counted as my answer. It can be incremented. My answer can be incremented by 1 because such a location like this definitely exists. Now there can, of course, exist more location than this. Maybe I want to check from this location or this location or this location or so on, so on, so on. There might be some more locations from which the knight is able to attack both the king and queen. And that's why the answer to this problem they have said is 2, which means that for a test case that looks like this, to their argument, there are only 2 positions from which the knight can attack both the king and queen. Similarly, the answer for the next case is 1. That means there is only 1 position. For this, only 2 positions. And for this, only 0 positions, as in no positions available. The knight cannot attack from any position on the infinite chessboard to the both king and queen together. Alright, maybe he attacks the king or the queen, but I want both of them to be attacked. That's not possible for the last case, so they have reported the answer as 0. So now you can pause the video and maybe draw these test cases on your own. Maybe use a pen and paper, draw a chessboard and see, and maybe try to cross verify if you're able to find these 2 positions or this 1 position from which you think that the king and queen are being attacked by the knight. Okay, so now what we can look at is the constraints and discuss what is our expected time complexity in this problem. Are we looking for some brute solution? Are we looking for some simulation? Or are we looking for some quick mathematics? All right, so let's go. I know by general fact that I have been allowed in 1 second 10 power 8 elementary operations. Now in this question, it's very clear that I have been allowed 2 seconds as a time limit for every test. That means one test allows me 2 seconds equal to 2 into 10 power 8 elementary operations. Now this being allowed, I have every test getting some test cases, that is this variable t, which is in 10 power 3 order. So if I ask you what's the number of operations you can actually perform for every test case, then you report 2 into 10 raised to 8 upon 10 raised to 3. This gives me 10 raised to 5 number of, or to be specific, this is 2 into 10 raised to 5 number of operations I get in every test case. Now this is very important because if I look at A and B over here, they're very huge. They are in 10 power 8 order. Alright, X and Y are also, like XK and YK are also in 10 power 8 order. XQ and YQ are also in 10 power 8 order. And even more to that, remember, you have an infinite chessboard. So infinite means it's expanding in the horizon. So of course it makes sense for me that I might not be able to go to every position and then be like, okay, at that location, should I check whether the knight and king are, whether the knight is able to attack both the king and queen? Is it possible for me to do this for every such cell? That's not possible, right? Because I have infinite number of cells to actually attack from where I could have attacked. So that is not feasible. Constraints are also very high. This means if I discuss, like if let's say assuming that my solution is dependent on any one of the factors, like because all the factors are in 10 power 8 order only, all the variables, sorry, are in 10 power 8 order only. So let's just say it's dependent on any one variable. Maybe let's say it's dependent only on A. That's in 10 power 8 order. So do you think you can create a solution that looks like O of A? No, you cannot, because that means I am running a solution that's in 10 power 8 order and every test case is going to allow me 2 into 10 power 5 order. That means this is not possible. So below this is what I need to explore. So just below this, a time complexity that might fit is the log powers, maybe log base 2a or even best, I create something like a constant solution. So I know that boundaries like this is not helping me. This is sort of a wrong solution, but boundaries in log terms or constant terms are pretty helpful. I know that they are going to fetch me the correct answer. And this is my hint in the problem. I'm going to look at the problem now in such a way that I try to bring my complexity as low as to log terms or even preferably a constant term. To do that, maybe I take the use case of some mathematics. I'm able to quickly calculate the answer, or I start changing my perspectives. And this is what is helpful when we have discussed our expected time complexity. Alright, so all the redundant ideas in my head are removed, specifically the idea where I could have actually taken up every cell as a position of attacking and placed the knight there and manually check. That is not going to work because I have infinite number of cells. So of course, I'm not looking at solutions like that. Okay, so now let's come to the main part. If we start off with our solution in our head where I actually consider every cell as being the attacking location of the knight, this is perspective 1. Perspective in this is basically I'm telling the knight or asking the knight from a cell, do you think you can attack both the knight, both the king and the queen? Let's just reverse this perspective and see how is it helping me. Not bothering ourselves with how the knight would attack, let's see about a king and about the queen. If I talk about the king, let's go back. I'll draw a simple chessboard over here. Let's say I have the king over here with me. So this is sort of a chessboard. Let's say I have the king at some location. Let's say it's placed over here. This is the king. Then understand this, that this king can be attacked from exactly 8 positions. Exactly 8 positions from the knight. Let's take a very simple example and see how is that happening. I mean, to be very honest, this is not exactly 8 positions always. If A is equal to B, in that case, when A moves are done and B moves are done in one side for the knight piece, then you're talking about 4 positions to be max. So it's at most 8 positions, but then if we consider very generalized cases when A is not equal to B, we want exactly 8 positions to happen. Now that will of course be handled later on when we'll realize in the code part. We'll come to that bit and we'll get that issue. How are we handling that part anyways? But for now, simplicity purposes, let's just take exactly 8 positions and visualize them. How are they happening? Let's just say that we forget about this A and B sort of a logic. Let's just imagine that your knight was a very simple knight you are all familiar with in the chessboard. It's going to perform 2 moves in one direction and 1 move in another direction. So I can very clearly observe that from this location, this, then over here it would be this, then over here it would be this and this, and then here it would be this and this. We can all understand this, that these 8 positions, if my knight is kept at any of these 8 positions, then my knight will be able to attack the king. Because if let's say the knight is kept at, let's say this location, then I can move 1, 2 in the down move, and then like 2 directions, 2 moves in the down direction, and then 1 move in the left direction. And yes, I'm at the king location, so I can attack the king. Similarly, if I'm at this location, maybe I can move 1 and 2 in the left direction and then 1 downward. So this is again attacking the king. So I can very well understand, like, this is no brainer that I have exactly 8 positions from which the knight could have attacked the king. Now, similar to this part, it's very obvious that if I draw the same chessboard with perspective to the queen, if I draw the same thing with perspective to the queen, let's say the queen is kept at some location like this, then queen will also be attacked by exactly 1, 2, 3, 4, 5, 6, 7, 8 locations from the infinite chessboard, if I am talking about the knight's perspective now. So why is this important to understand? First of all, we are not talking about the knight right now in this A and B manner. Forget that part. We are taking a general knight. So a general knight is attacking exactly 8 positions to the king. Similarly, that general knight would also attack the queen in exactly 8 positions. Now the question changes. If let's say the knight is not a normal knight in this case, and it takes A tiles in one direction, B tiles in another direction, what is the maximum harm that can happen? The maximum harm that can happen is, like, I'll keep this color as it is. Maybe I'll change my pen. I have a yellow color now. Assuming that let's say A was 2 and let's say B was 3. So what can happen maximum is your locations might change, right? That's all that can happen. Maybe if you're talking about 2 locations from here and 3 like this, so maybe something like this, maybe this location will work, right? 1, 2, then 1, 2, 3. So this is a possible yellow location from where the knight could have attacked. Yes, makes sense. What about this location? Yes, this also works. 1, 2, then 1, 2, 3. This also works. This is also a possible location. Similarly, there would be some location over here, right? And some location over here, some location over here, and some location over here. Then there would be some location over here and some location over here. So overall, I can see that I'm getting 8 locations now also. Now, will the argument change if I'm talking about the queen? No, right? The argument will not change. I will still get exactly 8 positions. They might be at some different positions that how a normal knight would have functioned, but still I would get exactly 8 positions in the queen itself. Exactly 8 positions in the queen itself. So now the problem is kind of changing. The perspective is kind of changing because we have solved our biggest challenge in this problem. We are not now bothered with infinite cells to check. Remember, you have exactly 8 cells from which the knight could have attacked the king. You have exactly 8 more cells from which the knight could have attacked the queen. So I'll take this on a new page. I'll write this down. 8 cells from which you can say knight attacks king. Then you have 8 cells also from which knight attacks queen. So if you have exactly 8 cells from which the knight attacks the king, exactly 8 cells from which the knight attacks the queen, can I not store them? I can store them because I know standing at a king's perspective, all I need to do is take up directions from which it moves. Let's say I'm talking about b equals to 3 and a equals to 2. So I want 3 moves in some direction and then 2 in another. So I can find out these 8 positions by brute manner. Similarly, I can find out these 8 positions in a brute manner. I have 8 cells, possible 8 cells stored up in some data structure for the king. Possible 8 cells stored up for the data structure in some data structure for the queen. What am I asked in the problem? Find the cells from which both king and queen can be attacked. So all I need to do is an intersection of these 2 data structures. If I have 8 cells over here, 8 cells over here, the common cells which will be present in both the set of king attacks and queen attacks, or king hits and queen hits, those cells will act as the cells from which if the knight would be standing at that location, he will be able to attack the king also and the queen also. So you can imagine this problem as sort of a set problem now. This is the set from which you have king hits, or these are the positions from where king can be hit by the knight, and then this is the set of locations where you have the queen hits. And this location, this sort of a region which is the intersection of both these sets is actually going to give you the positions which are valid from where the knight will be able to attack both the king and queen. And now all we need to do is keep a track of these positions and maybe finally report the count of these positions. How many positions do you get? And you will get the answer. Now this is going to work very fast because remember, we are not talking about an infinite chessboard. All I am doing is 8 positions, 8 cells in respect to the king and 8 cells with respect to the queen. When I find, like if you can mentally think of the time complexity you will get by only exploring 8 possible cells, you will understand that this is going to be very, very quick. Of course, highly within the boundary of 2 into 10 raised to 5, which we discussed. So of course going to work, and the logic seems right because I don't need to bother myself with any more cells now. I have already calculated the cells which were valid. I did that for the king, I did that from the queen, and I kind of intersected both. So I definitely get the correct valid cells. So the logic is correct and it's very, very fast. So definitely I'm going to get an accepted solution. Alright, so this problem is a very brute problem. Alright, it's not about thinking how you could have done this problem with some mathematics or something like that. All the hint in this problem was to understand if we change our perspective from that infinite chessboard checking to checks on some small set of cells, then this problem would have been very direct. And this is what the trick was. If we realize that this could have been done, you will very quickly get that, okay, the time complexity is going to be pretty low and I can just perform this quick number of operations and I'll get the correct answer, I'll get the correct number of positions. Okay, so I hope this is clear. Let's move on to the coding part and see how can we implement this. This is going to be specifically, you can say, not a very beginner friendly code. This code requires some sort of understanding. So try to be with this code piece. What we'll do is we'll take up A and B as input, then we'll take the input of A and B. So this is just very basic, taking A and B. Then I have the input of X king and Y king, that is the initial coordinates of the king and king in both X and Y directions. Initial coordinates of queen in X and Y directions simply, and then is what my main logic starts. So up till here, all I'm doing is taking inputs. Now I have taken a set data structure of the pair of int comma int type. Why pair of int comma int? Of course, it makes sense that I'm trying to store the cells. Cells are in X comma Y sort of a format. So I want a pair that can store this X coordinate and Y together as a cell. Why a set but? A set because I wanted a data structure which works in log terms. We discussed that we were looking complexities in log powers, and in a set it would be very easy for me to calculate the intersections since every check, be it insertion, deletion, or even finding, would happen in log powers. So this definitely helps. Added to this, why is a set even more useful? Because remember, in the start, we had discussed that since we are generalizing 8 positions exactly right now, because we are saying A is not equal to B, but it can happen that A is actually equal to B, and then you start visualizing not 8, but 4 positions. So we discussed that we would have 4 to 8 positions that we are depending on the values of A and B. Generalized, it was we took 8 positions since A was not equal to B, but if A is equal to B, you will get the same positions. But actually in the code, when we'll actually discuss further, how do we calculate the positions, it's very easy to see that since the formula that we are using over here, if we don't discuss what exactly right now is, we will definitely do this in some time, but just an overview is giving us a hint that we might get repeated insertions inside this data structure. So because this data structure is a set, repeated values will be handled for us. I know that a set is only going to maintain the unique pairs. So this makes sure that I'm not storing extra positions and I'm only storing the positions which are unique. As you'll progress along the code, you will also see why is this helpful. So I'll take up 2 sets. One is called king hits, one is called queen hits. As we discussed, we want the intersection of both. So before you want the intersection, we of course want to fill them up. How do we fill them up? So what I've done over here is I've taken 2 global arrays, dx and dy, and you can see there are some random -1, 1, -1 values declared in them. Now the argument here, these are not random. This is a very useful trick. So I'll just take up 2 minutes to make you understand this part. I have actually drawn up a neat diagram over here for this idea. We understand by simple mathematics that in 2D geometric system, the first quadrant is of positive x and positive y. The second quadrant is negative x, negative y. Negative x is positive y. Third quadrant is negative x, negative y, and fourth quadrant is positive x and negative y. What I've done is I have denoted them as positives and negatives 1. So over here in the x direction, you have +1, and then you have in the same quadrant y as +1 again. So +1 is a pair. Similarly, -1 +1 is a pair, -1 is a pair, and +1 -1 is a pair. So what I've done is I have jotted down all the x values, and corresponding to them I have kept at the same locations the y value. So if you go back, you can see over here that if the first value over here is -1, then the first value over here is -1 also in the dy. So -1 -1 creates this third quadrant pair. Then over here I have +1 in the second position and -1 in the second position. So +1 -1 creates this fourth quadrant. Then this -1 +1 creates the second quadrant, and then the last is 1 and 1 together, that creates the first quadrant. So I mean, I've just orderly made any quadrants come into picture, but that's not a big deal. What we are trying to picturize is now I have created quadrants for myself, and then if I go back to the whole diagram over here, you can see that let's say I'm talking about king right now. King is at some 0, 0 coordinate. From king's POV, you want 8 locations where knight could have been and it could have attacked the king. Observe this, that if let's say I'm talking about the first quadrant over here, if this is the first quadrant, in this quadrant, you are talking about positions that look like this. Either the knight is standing at AB, A comma B. From here, it can traverse like this. It can take up A and then B. So this is A, this is B. Or it is at B comma, where from which it can come down to A and then move B. So these are the 2 locations in the first quadrant where the knight could have attacked. Similarly, these are the 2 locations in the second quadrant. These are the 2 locations in the third quadrant. These are the 2 locations in the fourth quadrant. So what I've done is, again, this is an implementation difference. You can allot this problem. You can give if and else checks however you want, but this is just a quicker and a better method way how you would approach such problems. So when I understand this quadrant method, what I've done is I run a loop from 0 to 4, less than 4. So basically, I pick up one location from here and one location from here, and consequently, I get dx of j, and dy of j. They together give me one quadrant. Then what I do is I multiply those coordinate values in A also and then B also, and then in the other insertion I multiply it to B and then to A. So these two lines give me those 2 points in a specific quadrant. So once this runs in one iteration, I get for one quadrant, then another time it gets me for another quadrant, then another quadrant, then another quadrant. So I'm able to cover up 4 quadrants. Every quadrant I'm able to cover up 2 points, effectively giving me 8 cells or 8 points that are inserted in this king hits set. Pause the video, try to picturize this, do a dry run, and you will get what I'm talking about. And once you understand this, you can very well see that this is the same thing I'm doing on queen hits. So effectively, when I finally end the loop, I have inserted all the 8 possible cells very smartly, very quickly in the king hits also, and the 8 cells for the king hits in the king hit set, and 8 cells where the king could have attacked the queen in the queen hit set, sorry. Now, all that is left for me is to find intersection. To do that, maybe I can form some very intricate formula or something like that. But over here, my overall data set which I'm talking about is very small. All I'm talking about is 8 cells in king hits and 8 cells in queen hits. So if I want intersection or common, what I can do is simply, I can have an answer variable. Then for every position that is present in king hits, I can see whether it is present in queen hits also. As simple. This is a very quick brute solution. You simply say, is this position present that was present in king hits? Do you find that in queen hits? If you find that in king hits and you also find that in queen hits, you increment your answer by 1. And this finally, when you report your answer, you know for sure that you are printing exactly those number of positions which were present both in king hits and also in queen hits, effectively giving you your correct answer. So this is the whole problem. Very brute method, very implementive sort of a problem. All right, all we had to understand was that infinite idea, and this solution can be coded up in 10 different methods. I approach this method like this because this is the very standard method of how do we implement grid patterns, or how do we check in grid sort of a chessboard sort of a problems, and this was one of them. All right. So let's talk about the time complexity, and this is also very well realized why set was being useful. We have somewhere around exactly 4 iterations over here inside this, and then all of these iterations are log base 2 of the maximum size of set. Now maximum size of set can go to 8 because I can have 8 unique positions of king hits, or I'm talking about queen hits. So this is log base 2 of 8, and then that is happening everywhere in every line, so everything gets added up actually, but then you want to take only one term out of that, because effectively when time complexity are added up, we talk about the superseding term. So overall, I can see that up till here, the time complexity can be reported something like O of 4 into log base 2 of 8. Plus, then you can talk about this part. You have a for loop over here that's going to run maximum 8 iterations. You have 8 different locations in king hits. And then you have log base 2 of 8 check over here, which is for the queen hits. In that, it's a set. So set checks are log. So log termed, sorry. So you can have 8 into log base 2 of 8 over here. Now in this superseding term, of course, is 8 into log base 2. So I can just remove this part. I'm not bothered with this. 8 into log base 2 is going to give me exactly O of, you can say, 8 into 3, which means I am getting like 24 operations. So on an average, I'm getting somewhere around 24 to that limit of operations only. And this is very, very fast, right? It is almost constant. This, I cannot fully term this to be constant, but this is somewhere in the log powers only, because we can very clearly see where we are getting the log basis. And this is definitely less than 2 into 10 raised to 5, which was our very high upper limit. So will the solution work? Of course, this is going to work. This is getting me a accepted solution on the platform. All right. Now, what about the space complexity? All I'm using is this extra set over here, which can have a maximum size of 8. So you can say that I'm getting O of 8 space to store for the set. That's all. So the space is also very, very tuned up. It's very, very low, and the time is also very, very low. So this problem is good to go. I'm able to get a accepted solution on the platform. All right. So that's all in this problem. I hope you like the video. Thank you for watching.